The next question asks us to describe the motion of the car between 4 seconds and 6 seconds. Now, at 4 seconds, the car is moving in a positive direction at a velocity of something like, well, in fact, we've worked this out already, at 2.6 meters per second. And then at 6 seconds, it's moving in the opposite direction, but between that time, it has gone through 0 and it has changed directions. So what we need to say here is that at 4 seconds, the car is moving, we'll call it a positive direction, moving at 2.6 meters per second in a positive direction. It then slows down, it accelerates negatively. We don't use the word decelerates. Try and get away from that. So it slows down with an acceleration, and it's obviously getting slower, so the acceleration is negative, and I could very quickly work it out. It's going to be 0 minus 2.6 over 1 second, so it's going to accelerate negatively at minus 2.6 meters per second squared. At that point, it is stationary for just an instant. And straight after that instant, no time at all really, it starts moving in the opposite direction, i.e. in a negative direction. Now, it's also going to be accelerating in a negative direction, and of course, we've worked this out already, because between 5 and 7 seconds, it was moving, well, between 5 and 7 seconds, its acceleration was minus 4 meters per second. So when it's turned around turns around at 5 seconds, moves off in the opposite direction, which is an acceleration of 4 meters per second. Or it accelerates at minus 4 meters per second, but it's going in an opposite direction, therefore it's getting faster and faster. Now, words to that effect, just as long as you understand what I've been going on about, you can work it out for yourself. Now, the last question says, where is the car in relation to the start line 8 seconds after it starts moving? Okay, now here is 8 seconds after it started moving. There it started moving. And what this question is saying, find out the position of the car after 8 seconds, which means we have to find out how far it went. Now, take note, in this first 5 seconds, from 0 to 5, it was traveling in a positive direction. From 5 to 8 seconds, it's traveling in a negative direction. Now, what we need to do is to find out how far it moves positive and how far it moves negative. And of course, you know the trick. It's work out the area under the curve. And so what we need to do here is work out the area of that triangle, which is half base, half times 1 second times perpendicular height, which is 4 meters per second. Here is a rectangle, which is 1, 2.5. So it's 2.5 seconds times 4 meters per second. You can see that that's 10. And this is 1.5 seconds times 4 times a half. Well, 4 times 1.5 is 6, times a half is 3. 1 times 4 times a half is going to be 2. And so I can see that it's 2, 10, 15 meters it's moved from the starting point 15 meters in a positive direction. Now, if I go through that whole thing again here, I find a triangle between 5 and 7 seconds. So half base is half times 2, which is 1, times this perpendicular height here, which is minus 8. So it's 1 times minus 8. And it is 1, because here's a rectangle, 1 times minus 8, which is also minus 8. Oh, jolly good. So it's going to move in the other direction 16 meters. So in fact, what we find is that it is 1 meter back from the start line. Now that is not the start line because this is a velocity time graph. So in other words, if you looked at it starting here, it went 15, it then came back, and it went 1 meter past the start line, and that's where the story ends as far as we are concerned. Okay, short pause for food for thought.
Learning Channel offers an extensive educational collection ranging from grades 8 to 12 in alignment with the National Curriculum Statement. We offer DVD and workbook sets in a number of different subjects. To buy the Learning Channel series, check out our website on www.learn.co.za or call us on 011 639 0179.